And now our special featured speakers tonight. First, we have Foojay, we have Jürgen here, and he's the Senior Director of Open Source Projects at Azul Systems. He's the leader of and author at Foojay.io and PMC Chair at Apache NetBeans, and also a Java champion. Then we have Melissa McKay, my good friend. Yeah, Melissa and I met, I remember, at DevNexus, I think. So Melissa is a developer advocate at JFrog, a Java champion, a longtime developer turned international speaker. And her background and experience as a software engineer span a broad spectrum of languages and tools in enterprise products and services space. She's also a mom, a software engineer, a Java geek, and a huge fan of conferences. So welcome again, Melissa. Welcome, Jürgen. I will pass the baton on to you, Jürgen, first to tell us about Foojay. So thank you.
Perfect. Thank you so much for that great introduction. So I'm Geertjan. I'm in Amsterdam, in the Netherlands. I used to work in Sun Microsystems and then in Oracle, and currently in Azul. And I want to, in just about 10 minutes, introduce you to what Foojay is. So I'm at Foojay.io, and you'll see a page with information all about Java and the Java ecosystem that I'm going to go through briefly. But the simplest way to explain what it is for many people here who might be aware of Java.net. So back in the day in Sun Microsystems, there used to be a site, java.net, where you had a blog, where you had information about the latest releases of Java, where you had information about the community, where there were opinion polls. It was basically the place you went to as a member of the Java community. And it was a launching off point for getting started with Java as well. Now, of course, well, as you can see, we're sorry, the java.net site has closed. So there's been a gap ever since this happened. So Oracle stopped doing this. And so over the years, there hasn't been anything to replace it. So what we have with Foojay is an attempt to do just that. Now, to begin with, who are the people behind Foojay? Here are the different organizations that are involved in it, who are backing it, who are actively involved in Foojay. So Sneak, Payara, JFrog, Hazelcast, DataStax, Datadog, and Azul. These are the organizations who have taken the initiative to put together Foojay. Now the question you might have right in the beginning is, what does Foojay actually mean? And Foojay is a combination of these letters from these words, Friends of OpenJDK. So the F of Foojay comes from friends, and then the first O comes from of, and the second O comes from OpenJDK, and then there's a J from JDK, and then we would have Fooj, and you wouldn't know how to pronounce it, and so we've added A and Y, so it's clear that you say Foojay, and now that we have Foojay with J-A-Y in it, we have a bird, which gives us a nice logo. And of course, in the Java language, we are very familiar with foo and bar as placeholder variables in sample code. And so you should really see Foojay as being a place where you can put your own content. It's a placeholder for your engagement in the Java community. So Foojay is a place for friends of OpenJDK. It's not a place for developers of the OpenJDK. So we do have OpenJDK.java.net. So if you're working on extending OpenJDK itself, if you're a developer of the OpenJDK, then that's where you would go. But for the vast majority of Java developers, of course, you're not actually contributing to OpenJDK. You are simply using the OpenJDK. You're a friend of the OpenJDK. And so for all those millions of people, we have the site which gives you a whole range of insights into Java. And to promote this, so this is actually a site that has existed since April last year. So we're almost at the first year of existence of Foojay. To promote and celebrate this, to celebrate the Java community and to promote Foojay, we're doing a tour around to as many JUGs as possible within March and April. And so we have about 10 stops we're doing in March and about 10 in April. So this is one of the stops. So we've been to Munich with Simon from Sneak, and to Bonn with Garrett from Azul, and we went with Steve Chin to the Denver JUG, and so on and so on. So now we're down here on the tour with Melissa presenting on the topic that we know we're going to be hearing about in a few minutes, level up your Java containers. But there's many more stops on the tour. But to briefly introduce you to Foojay itself, now that you have a bit of that background, in the Java ecosystem, we know, of course, that there are now many different updates. So there are quarterly updates of the OpenJDK. Now, does anyone actually know what is in those updates when a new update comes out? So there was the January update just recently for Java 8, but that same update also applied to Java 11. So in that particular update, there were fixes for Java 11 and for the other releases. So each of the major releases receive an update every quarter. Where would you go to find out what fixes have been integrated into that quarterly update? Now with Foojay, we provide a list of all the issues that have been fixed for a particular update. So in the January 2021 update for Java 8, here are all the fixes. So here's a whole list of those fixes. So then the question is, okay, how do I make sense of this? So we've broken it up into the components. So this component view gives you a view on the fixes per component. So in hotspots for the January update for Java 8, this is what happened. So here are all those fixes. So the idea is that you'll go through this and you'll just browse through and take a look at all of these fixes that have gone in, and that you say, hey, this is interesting, and that you click on this. So there's no logging in. You just vote by clicking on one of the stars to say, hey, I like this particular fix. And by voting, by clicking on those stars, you increase the stars for a particular fix, and the highest 20 fixes find their way onto the highlights page. So the highlights page actually gives you a view onto what the community thinks are the most interesting or useful fixes for a particular update of a particular major release. And so once people have voted on this, what we do in Foojay is we provide commentaries. So here, for example, a lot of people thought that the Marlin renderer fix in the April 2020 update for Java 8 was interesting. But from this title, so this is the title of that issue, do you have any context about what is actually fixed in that particular issue? It's really unclear what this means. So we provide a Foojay commentary. So here, JDK 9 switched to using the higher performing Marlin renderer. This is a backport of that feature to JDK 8. So what we want to do in Foojay is we want to highlight and to draw attention to, in this case, the fixes of particular updates for particular major releases. But what we also want to do is we want to present a list of the OpenJDK distributions. So since the time of Sun Microsystems, of course, there hasn't only been an increase in the velocity and the tempo of Java releases, there's also been an increase in the number of OpenJDK vendors. In the time of Sun, of course, there was Sun. But now when you say Java, what do you mean? Do you mean Oracle's distribution of the OpenJDK? Do you mean Red Hat's distribution of the OpenJDK? And then there's also non-OpenJDK distributions. But here on Foojay, we focus on the OpenJDK distributions. And here you can see where you can find the various, first of all, which ones there are. So Alibaba has a distribution, Bellsoft, Azul, and also what the new features are and so on. So if you look at, for example, the Red Hat site, you will only find out, of course, about Red Hat's OpenJDK distribution. And if you go to Bellsoft, you find out about Liberica. But where would you go to find a complete list of the OpenJDK distributions? So that's what Foojay is for. It's a meta layer on top of the different distributions. Another example is where would you go to find the complete list of JVM command line arguments per release? And where would you go to find out what the differences are in terms of JVM command line arguments per release? So here you can see for Java 11, these are the JVM switches that are new in Java 11. It's the 53 you can see here. And here's a list of those that have been removed. Where this comes from is from chriswhocodes.com, which is a site by Chris Newland. Like this open JDK distribution information comes from JavaAlmanac.io by Mark Hoffman, another Java champion. So we're working together with various Java champions and other people involved in the Java community to integrate their content into Foojay. So you would have to know that this site exists in order to go there. You would have to know that this exists in order to go there. But what we want to do is we want to provide a platform for as much Java content around the ecosystem as possible, to provide a common place for people to go to. Now, once we have that content, so information on the updates, on the OpenJDK distributions, and on the command line arguments, another interesting area to look at is, what about if we provide tips and tricks and blog posts and other content together as a community? And so that's why we have Foojay Today, which is basically a blog. And every day there is one article that we publish on Foojay. And we decide that together on the Slack channel. So here is the Foojay Slack channel, which you're very welcome to join. And once you're on here, you'll find that every Monday morning we schedule content. So we say, hey, what shall we post this week? And we've decided to do one a day. And so here you can see a proposal, and we discuss this together and so on. And the content you can put into Foojay yourself. Foojay is simply a very highly customized WordPress site. And of course, WordPress is horrible in many ways, but it does the job. You can get a user and password credential to the Foojay site. You will then put your content in draft form, and every Monday morning we discuss together which ones we will post. And that's really how we work together, how we collaborate together. What's interesting here as well is these different categories. So for example, let's look at the release notes. So in the release notes category on Foojay today, we see as many release notes as we can manage to find and as people want to contribute to Foojay in one place. So here, as I'm reading about the Payara release, so I might have come here to read about Payara, then I find out, hey, there's also an Oracle WebLogic release. I mean, if you were on the Payara site, you would never learn about the WebLogic release. If you're on the WebLogic site, you would never learn about the Payara release. And so by gathering as much of these release notes together into the same place, we provide an opportunity for people to learn about different related technologies at the same time. So that's one interesting area one opportunity for every Java organization to not only publish their release notes on their own site, but to also republish on Foojay to make it available to other people who might never come on their site, but who would find out about their release by means of Foojay. Another example is we have here a whole area that deals with tools. One of these tools is Intellij. So there's lots of content here by Helen Scott, a developer advocate from Intellij. So we have authors and we have community managers. So if you find a particular area of Java interesting, you can take ownership of that area and gather content on Foojay around that. And one topic that Helen wrote about that is really interesting is, well, this one, Intellij made me lazy, but also wrote an article on Intellij called New to Intellij Me Too, except I can't find that article. Oh, interesting. Well, anyway, she wrote this really interesting article here. So we go to the next one. She wrote this interesting article about using Intellij as a beginner. Now, normally, if you get started with a technology, there is a very nice Hello World story on a site with 5 perfect tips with things going absolutely perfectly. But more likely, things go wrong. And so here is an amazing article where she describes how she got started with Intellij and all the hoops she needed to jump through. And in many ways, this is a much more realistic Hello World scenario than the official Hello World scenarios. Now imagine if we were to have new to JFrog, me too. New to Payara, me too. So these would be the real hello world scenarios. And so that people wouldn't get stuck on step 2 of the perfect 5-step hello world tutorial, but instead they would come to Foojay to find out how things really go wrong, but then go right in the end. So to be an encouragement to people getting started with a particular Java technology. So there's all kinds of interesting ways in which we can share information that Foojay provides a platform for. Now, of course, we have a Twitter, and there's Foojay.io. Every day, if you follow Foojay.io on Twitter, you will get a tweet promoting the latest article that we've published on Foojay. So that was my brief introduction to Foojay. Foojay.io is the place to go for all information on the latest Java releases on the open Jdk distributions, and also where you can blog. You can repost existing blogs or write completely new ones. There's a poll, there's an event calendar, of course. There's terminology. So there are terms like TCK and CPU and PSU that are specific to the Java ecosystem. And here you find out what those terms mean. What are compact profiles? So those are not blog posts, but these are definitions. And if you have a nice tweet, we also highlight your tweets in the greatest tweet area. So it's a one-stop shop, free place for all Java content, backed by leading members of the Java community and leading Java organizations. I've been really happy to be working on this project since April last year in Azul. I'm really happy that Azul is sponsoring this, and I'm really happy that there are so many organizations that are backing this project as well, and more are joining. So Hazelcast joined quite recently, and we still have to announce this. So join in, and let's provide a central place for all Java content that we've been lacking for so many years. Thank you.
This is great. Thank you, Jürgen. Yeah.
Sure.
I guess maybe before Melissa starts, let's find out if anybody has any questions for Jürgen right now.
Yes.
I guess for me, I'd just like to know if folks wants to join your Slack channel, how would they be able to join? Is there a link somewhere on your site?
Yes, there's a link on the site. At the bottom, you find a link. Here's our Slack. Here's the link down here. Or if that doesn't work, or if it's out of date, just send me a mail, and we'd be happy to invite you directly. We also have that link on Twitter. Yeah, and here is where we have all of our discussions. So this is really the place where all the discussions around Foojay happen. So it's really the central discussion platform.
Okay, great. Thank you. Thank you, Jürgen.
Thanks so much. Let me stop sharing.
Question? Yeah. Hi. We have some questions on this, Ken.
Sure.
Sanjay, you have a question?
Yeah, thank you for giving introduction about Fuji. So let's say if I have some questions about Intellij, is there where can I post it in the site or in the Slack? How it works? Or that option is not there?
Well, that's a good point, actually. So the question is really about a forum. So right now, Foojay doesn't have a forum yet. And we've been thinking about integrating with Stack Overflow, so that the Java section of Stack Overflow would be integrated into Foojay, and then you would be asking a question about Intellij on Stack Overflow in the Java section, and then it would appear on Foojay. Or you would see an article on Foojay about Intellij, and then in the comments to that article, you could leave a question. Or you could join the Slack channel, the Foojay Slack channel, and there is a general section there where you can have discussions. Or we can set up a special channel for Intellij specifically, where you could ask questions. So all those different ways are possible.
Oh, okay. Thank you.
Sure.
Someone else asked another question in the chat window. You can look into that.
What technologies are used to build the Foojay site? It's purely a WordPress site. And WordPress in every possible way is horrible, except that it does the job. And it's been working well for us. It's highly customized WordPress site. There's a full-time team that works on Foojay. Yes, no Java. So this is the first implementation of Foojay as a WordPress site. Ultimately, what I think would be great is if we were to do a Java-based Java technology site, that we would develop it on GitHub, and that people could do pull requests directly into the Foojay site on GitHub. I think that's where we want to go to ultimately. But for the first implementation, we simply wanted to get the job done as quickly as possible and not reinvent the wheel from scratch. And so we went with WordPress because it provides the basic infrastructure that you need for a site like this. Thank you.
Sorry, I was muted. I guess looks like we don't have any more questions for now for Jürgen. And Jürgen, you're still hanging out, right, until
yes, I am.
Melissa's done. Okay,
yes,
so we can ask more questions afterwards as well. So,
please do.
And then, so thank you, Jürgen. Yeah, thank you about telling us about Foojay. Thank you. And now we'll have Melissa, and Melissa it's over to you. So
great. All right, let me share my screen here. Move everything around. We're all getting very good at this part. All right, well, I am Melissa McKay. I'm a developer advocate with JFrog. I'm really excited that this talk became part of the Foojay tour. I've given it a few times now, and I really enjoy it. I hope you do too. Just to set some expectations up front, there's a lot of information about Docker in this talk, but this is not a tutorial or a deep dive on Docker commands or anything. There's a ton of documentation already out there on that, so I didn't feel that was necessary for this talk. When I put this one together, I wanted to do something a little bit different. I wanted to do some background research and focus more on how we got here and get to some answers to some of those big why questions, why we're doing any of this. My hope is that after this, you'll come away with a better understanding of the history behind containers and how they actually work on your system and some of what's really going on under the covers. That said, I'm excited to share with you today some things I've learned about containers. So first of all, this is very important. I'm not going to linger on this slide too long because we have a lot to cover. So grab your phones, get this QR code or take a screenshot or whatever you need to do so you can get this link. This is where my slides will be. You're probably going to see some links in this deck that you might want to look at later. Don't fret because this deck will be available for you to look at this location. Also, JFrog has some cool t-shirts to give away, 5 of them actually, as well as a JFrog Yeti Rambler, pretty cool. And this is where you can enter the raffle during the session and for a limited time afterward in order to get yourself one of these. I'm wearing my t-shirt tonight. You probably can't tell much in the tiny little window here, but I'm actually based in Denver, Colorado, and we just dug ourselves out from a ton of snow. And I'm just refused to acknowledge it. And I continue to wear my t-shirts, hoping that winter will get on its way out of here. All right, where I came from, my background is in software engineering and development. I've been a developer in some way or shape or form for the last 20 years. Most of my professional experience has been in server-side development and Java, but I've been on many different teams, working in many different technologies, languages, and different tool sets. I started speaking a few years ago. That was something I wanted to do more of, so I made the jump to the developer relations team with JFrog last February. That means I just had my 1-year anniversary here, which is pretty awesome. It's been an incredible experience, especially with everything online. That's very different than physically going to conferences and stuff like that. But we've gotten the opportunity to speak to a lot of folks that maybe we wouldn't normally be able to. So it's been good in some ways. My most recent experience in development pushed me into some new territory. This was while working on a team that was beginning to practice DevOps. And I got the privilege to learn about how the apps I've been working on, how they were actually packaged and deployed, and got a lot of exposure to a variety of tools in the ecosystem. One of those tools is Docker, and that's actually how this talk came about, collecting information from my own experience and learning how to containerize my apps, some of it trial and error. So now that you know where I'm coming from, let's get started. We'll start with a brief history to give some background context. Hopefully this part won't be too boring, but there are some important milestones in the past that are good to know and to get a better understanding of how we got here. We'll take a look at the container market and what's been going on there the last few years. Then we'll move into getting a real understanding of what Docker is. Docker is not synonymous with containers. I'll repeat that. After that, we'll be in an excellent place to talk about what a container is. Then we'll review a few common container gotchas, some that I experienced myself. And last but not least, I'll talk to you a bit about an option for managing your container images. All right. For all of you that are online, I'd love to see your answer to this in the chat, how you are using containers or not using containers today. There are two reasons I'm showing this. I just want to know, if you haven't considered this, there are some very good reasons for containers, using them other than for production. So I'm always curious to know who's using them to test, even if they're not using them for their production systems. The top two, using them locally, using them for test environments. These provide consistent environments in testing or QA environments where you can still gauge the quality of your applications with significantly less resources than a production environment. All right. So I'm sure that this isn't the graphic you were expecting to see. Normally with these talks, you see a classic shipping container photo, and there's actually a couple of reasons I chose to show bananas here. First and foremost, I'm just tired of seeing shipping containers on every presentation about Docker and containerization in general, so I've started a bit of a rebellion on that. So I hope you enjoy the banana theme throughout this talk. Second, this is really a story about how our industry has adapted to dealing with limited resources over time. And when I was putting these slides together, I was reminded of a story that my grandfather would repeatedly tell me when I was growing up. I'm sure just to remind me to be grateful for what we have today. When he was a kid, he would get a single banana once a year on Christmas. And this must have been during the early 20s and early 30s. Bananas were a pretty rare treat during that time for my grandfather's family, and none of that banana would go to waste. He and his brothers and sister would scrape that banana peel with a fork to get every last bit of banana because they wouldn't be getting another one until the following year. So that might not be the most solid analogy, but I liken that story to how computing resources were in the 1960s and 70s. Very limited and very expensive. And on top of that, it took forever to get anything done. Often a computer would be dedicated for a long period of time to a single task for a single user. And obviously, the limits on time and resources created bottlenecks and inefficiency. And just being able to share was not enough. There needed to be a method to share without getting in each other's way or having one person inadvertently causing an entire system to crash for everyone. The need for better strategies in sharing compute resources actually started this path that we're on today of innovation. We see massive benefits from this today. There are some key points in time that brought us to the state we're in today with containers. And I'm going to begin our container history lesson with Chroot. Chroot was born in 1979 during the development of the 7th edition of Unix and was added to BSD, that's the Berkeley software distribution, in 1982. Being able to change the apparent directory, the apparent root directory for a process and its children, which Chroot allowed you to do, results in a bit of isolation in order to provide an environment for testing a different distribution, for example. All right, hang in there. You're going to get a lot of data on this slide, but this is important stuff, so pay attention. The jail command was introduced by FreeBSD in 2000. Chroot was a great idea and solved some specific problems, but more was needed, and the jail command came about. Jail is more sophisticated than Chroot in that its additional features help further isolate file systems, users, and networks, and has the ability to assign an IP address to each jail. In 2004, Solaris Zones brought us ahead even further, giving an application full user, process, and file system space and access to system hardware. Solaris Zones also introduced the idea of being able to snapshot a file system, which is pretty important. In 2006, Google jumped in with their process containers, later renamed C groups. You might recognize that term, C groups, which centered around isolating and limiting the resource usage of a process. We'll talk a little bit more about C groups later. Moving right along, in 2008, C groups were merged into the Linux kernel, which along with Linux namespaces led to IBM's development of Linux containers. 2013 was a big year. Docker came on the scene, bringing their ability to package containers and move them from one environment to another. The same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own subcontainers. From here, we saw the use of containers in Docker specifically explode. In 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. I thought that was interesting to find Golang in this history of the development of containers and Docker specifically. I'm almost done with this lesson. I'm skipping over some details here around different projects, organizations, and specs that came out because I want to get what happened in June of 2015. This event is important to know about because it will give you some insight into some of the activity and motivations behind the shifts in the market. The Open Container Initiative was established. This is an organization under the Linux Foundation that includes members from many major stakeholders, including Docker, with the goal of creating open standards for container runtimes and image specification. And while all of this is happening in the container world, there are a couple of other dates that are going to be important to us Java devs to know specifically. Remember that this happened in July of 2011. Java 7 was released. And then work was started on Java 8, which was released in March of 2014. So keep those dates in mind, just because when you start containerizing your Java applications today, when many of us are still on Java 8, I'll be bringing this up again later, but this is a bit of history that's important to remember. All right, that's it for history. Let's move on to something more interesting. Let's take a look at what's been going on in the market recently concerning container runtimes. So I did a little hunting. I found out for the last several years, Sysdig, a company that provides a really powerful monitoring and troubleshooting tool for Linux, and some of you might be familiar with this and have used it, they've put out a container report based on analysis of their users. Part of the report includes data on container runtimes that are in use. In 2017, they analyzed data from 45,000 containers. There's no graph available because 99% of the containers were Docker, so they didn't bother splitting up those results. In 2018, however, they doubled their sample size, and 83% were Docker containers, 12% CoreOS Rocket containers, 4% Mesos and 1% LXC. So it looks like at this point, other container runtimes are starting to encroach a little bit on Docker. Moving on to 2019, the container report included stats from over 2 million containers. Now we have a significant data source here. Docker is still holding relatively strong, 79%, 18% is Containerd, but it's worth noting that Containerd is a runtime that Docker actually builds on top of. That last 4% is Cryo. Last I knew, Cryo is an incubating project still with the Cloud Native Computing Foundation. This data is interesting because of what's been happening the last few years. Something to note here is the disappearance of Rocket, and that's kind of a sad story. CoreOS was acquired by Red Hat at the beginning of 2018. Prior to that, Rocket was accepted to the CNCF, the Cloud Native Computing Foundation, as an incubating project and looked like a promising competitor to Docker's Containerd. However, since the CoreOS acquisition, the development of the project went dormant, and in mid-2019, Rocket was archived by the CNCF. In February 2020, the project was ended. I'm pretty unfortunate because it looked to be pretty promising, and they had a different model for security, and you can actually still use them. The project is still available if you want to use it, but no one's maintaining it right now. All right, in January, this is the latest SysDig report that came out for 2021, I assume for the prior year or previous year. It's hard to know here if we're comparing apples to apples just because of that little qualifier, a subset of customer containers, but we're still at 2 million containers, so pretty good source of data. This report includes a ton of detailed information about their demographics and data sources, as well as other information around what services customers are running, as well as what they're using for orchestration. And in a nutshell, what I pulled from it was this. Notice there's a huge increase in the usage of Containerd from 18% to 33%. And it'll be interesting to see if that trend continues, especially since Kubernetes announced they will be deprecating support for the Docker runtime later this year. So now that I have introduced a few of these other container runtimes that exist out there besides Docker, it's time to start talking about what a container actually is and what Docker actually provides in order to appreciate the differences between them. So what exactly is Docker anyway? This is a key point. What Docker had over other players in the container game was a focus on commoditizing a complete solution that made it possible and easy for developers to package and deploy their applications. Once containers became easy to use, we all witnessed the explosion of tools and resources around containers, and the Docker image format became the de facto standard in the market. The stats that I showed earlier from SysDig are specific to container runtimes. That terminology is important to understand here. I'll explain the pieces and parts involved in working with containers, and you'll immediately understand why Docker sucked up that market so quickly. So as users, let's think about what we actually need to get our apps out there and running. Often we can find ourselves getting so far down into the nitty-gritty details that we lose sight of the actual problem we're trying to solve. And I love telling this story. It reminds me of my first job as an intern. I had an amazing boss. Whenever he would say this, whenever you start overthinking something or stumbling around to make a decision, always go back to the original problem you're trying to solve. Keep asking yourself that question. What problem am I trying to solve? Ask yourself if the move you want to make next is getting you further or closer to solving that problem. And I use that advice to this day. So here's a list of needs broken up into discrete features. First and foremost, we need that container itself. Some of you might be asking about virtual machines at this point, and discussing VMs is out of the scope of this session. But the one important thing to say about virtual machines is they are not the same thing as a container. The biggest difference being that a VM includes an entire OS all to itself, and containers share the system's OS. I know a lot of you that are using containers right now are like, yeah, we know all this. But I always like to go back to the basics because there's always someone out there that's just starting with this. And I was one of those people, so I empathize completely. The point of the container is to be lightweight and have the ability to move from one environment to another seamlessly and quickly. So that said, I know there's a lot of developments going on right now in the VM space, but that's a different topic. So the rest of this list, the image format, we need that to define a container. we need a way to build an image of a container. We need a way to manage those images. And we need a way to distribute and share those images with each other. We need a way to create, launch, and run a container environment, and a way to manage the lifecycle of those running containers. And I didn't even get into orchestration or anything, but this is plenty to prove the point I'm making about Docker. So in the context of those developer needs that we just went through, Docker was ready with an answer for everything. You want to start using containers? Well, here's the Docker engine. You need an image format? Here's the Docker image format ready for you. You need a way to build an image? There's the Docker file, and you can call Docker build. You want to manage images? Call Docker images or Docker remove. If you want to share your images or use an image from someone else, you can call Docker push or Docker pull, and there's Docker hub, where you can store and share your images with each other. You need a way to launch, run, and manage your containers and their life cycles. Call Docker run, Docker stop, Docker PS. Docker succeeded in quickly meeting the immediate needs of a container-hungry market. And on top of that, the tool sets that Docker provided made it all easy, which is a huge plus for developers. It was enough to walk away with a tremendous part of the market share all the way down the aisle. And I just want to say, I hope you appreciate the graphic I used here. It took me forever to find something that even remotely made sense for this slide. So there we have wedding rings and bananas. All right, remember in our history lesson when I spoke about the Open Container Initiative, I'll start saying OCI just because it's easier for me. Out of all of those features that we just discussed that Docker offers, there are two that were taken up for the cause by the OCI, the image format and the container runtime. Actually, there's another one, container distribution, that just came out that I've started looking into. That's another one that they've parted out and are getting involved in. Docker did quite a bit of reorganizing their code base, and they developed a bunch of abstractions, pulled out discrete functionality. They are a heavy contributor to the OCI. In fact, they gave the Docker v2 image spec as a basis for the OCI image spec, and RunC, which was contributed as a reference implementation of the OCI container runtime spec. There are quite a few other container runtimes you might see out there, including Containerd, Cryo, and Kata, all with various levels of features for specific use cases. Remember earlier I mentioned that Docker actually builds on top of Containerd. Containerd was actually contributed by Docker to the CNCF, and internally it uses RunC. Containerd was integrated into Docker and has been in use since Docker version 1.11, which came out in 2016. So it's been out there a while now. The next few years are going to be pretty interesting to observe what happens with these specs and how the OCI moves forward. Like I said, there's a distribution part that's happening right now. There's quite a range of differing opinions about what should and should not be in the standard for a container runtime. And we're in a situation where having a runtime that just meets the requirements of the OCI spec doesn't seem to be enough to drive adoption. There's not enough there to make it easy enough for people to pick up and run with it. I've added a couple of links here that are excellent starting places to learn more about container runtimes if you're curious. I know there's a lot of overlapping definitions, and there's a lot of explaining that goes on in these links. The second link is the beginning of a blog series by Ian Lewis, a Google Dev Advocate. And the first subtitle in that blog attracted me. It was, "Why are container runtimes so confusing?" And Ian does a really good job succinctly explaining some of this and goes into details about how low-level and high-level runtimes, how they might overlap. So take a look at those articles if you want to dive deep and understand that a little bit better. All right, with those details about Docker and some of what's going on in the market, let's just focus on the container itself and what a Docker container actually looks like on your system. I'll show you how it's stored and what is actually happening under the covers. you'll discover pretty quick that images and containers aren't all that magical. So my first experience with containers was as a new developer on a project with a tight deadline, of course. That's probably a good description of most projects. And the best course of action for me in general is just to jump in and start getting something up and running on my local machine. I learn best by doing. And the Docker documentation is actually really good. So if you find yourself in a similar position, definitely go through their Getting Started docs. I've linked those here. Going through this guide will get you comfortable with some of the commands you're going to need. And the first thing to note is that a Docker image is really just a tarball of a complete file system. When an image is unpacked on your machine, it's just thrown into its own directory, which becomes its root file system. The second is that the processes that are involved in running the containers are just regular Linux processes. On top of that, there are just a few Linux features that are used together in a way to achieve the isolation that we want to need from containers. Namespaces are an important ingredient because this is what is used to provide virtual separation between the containers. And this is how the processes inside a container don't interfere with the host or processes inside another container on the same host. And here you can see I have, there's namespaces that were set up for a Postgres container that I have on my box. The cgroups functionality is pretty essential to constraining how much a container can use things like CPU, memory, network bandwidth, etc. And I can set these constraints by including options on the Docker run command when launching an image. And here you can see that I've constrained my memory usage limit here on one of my containers that I have. I'm going to gloss over some file system details. I was super curious what's actually going on when I was building and running containers and storing them. So where they are actually stored on your file system. First off, after you've installed Docker, which I just installed Docker for Mac, that was easiest for me on my machine locally. Running the command docker info will spit out a bunch of information about your installation, including the Docker root directory. And this is where most everything you're going to care about regarding your Docker images and containers are going to be stored. Note, if you're on a Mac, your containers are actually running in a tiny VM. So you're going to need to use a tool like Screen or something to get in there and get to the Docker root directory to look around. If you're not familiar with how to use the Screen command, since I've recommended that one, definitely Google that, get familiar with it first, because it'll mess up your text display pretty good if you don't enter and exit it the correct way. This slide shows how you can get information about the images that you have stored on your system. First, I listed my available images using the Docker images command. I actually have several installed, but only the first couple in the list are displayed here. Using the Docker inspect command, I can inspect any image I like using its image ID. This will spit out a ton of interesting information, but what I want to highlight here is the graph driver section, which contains the paths to the directories where all of the layers that belong to this image actually live. Docker images, and when I say live, I mean stored on your machine. Docker images are composed of layers which represent instructions in the Docker file that were used to build the image originally. These layers actually translate into directories on your system, and these layers can be shared across images in order to save space. The lower dir, merge dir, and upper dir sections are important to know about and understand. The lower dir directory contains all of the directories or layers that are used to build the original image. These are read-only. The upper dir directory contains all of the content that has been modified while the container is running. If modifications are needed for a read-only layer in lower dir, then that layer is copied into the upper dir where it can be written to. And that's where you might have heard the copy on write operation. That's what that's called, and that's what it is. That's what's happening. It's important to remember that the data in upper dir is ephemeral data. It only lives as long as the container lives. In fact, if you have data that you intend to keep, you should utilize the volume features of Docker and mount a location that will stick around even after the container is shut down. This is how most containers running a database, for example, are run. Lastly, the merged dir is kind of like a virtual directory that combines everything from lower dir and upper dir. And the way the union file system works here is that any edited layers that were copied into upper dir will overlay the layers in the lower dir. And that's what you see when you're looking at your image. All right, this slide shows I have a few containers running on my system. 2 of them are my local JFrog container registry installation, which includes a container for Artifactory and a container for a Postgres database. The other is just a simple test container that I was playing around with. Note that the container IDs of the running containers match up with the container subdirectory names. Something to remember here is if I stop a container, that corresponding directory doesn't automatically go away until the container is actually removed with the docker rm command. So if you have stopped containers lying around that never get cleaned up, you might see your available space start to dwindle pretty quick. There is a docker system prune command that you can run every now and then to help clean things up, or you can launch a container with a flag to indicate that it should be removed when it's finished running. Lots of orchestration will take care of that part for you. So this is just if you're running Docker containers on your machine locally. The tool sets around building and running images and containers have made things so easy now that it's also easy to shoot yourself in the foot in a few places. And I see this repeatedly. I'm going to go over some of the most common gotchas, including some JVM-specific gotchas that I ran into immediately a few years ago when I first started working with containers. So the first is running as root. Running a containerized application as the root user. And I'll be honest here, completely honest, when I was initially getting containers up and running, I was just so excited about how well it was working that it was a while before I took this one seriously. Now that you know that processes inside a running container are just like any other process on the file system, albeit a few constraints, it's scary now to run as root inside a container. Doing that opens up the possibility of a process escaping the intended confines of the container and gaining access to host resources, which is the real problem. You want to always reduce the attack surface of your container by following the principle of least privilege. Although containers are designed not to affect other running containers, if someone were to gain access to your container and they have immediately they have root privileges, they can wreak havoc on their host. So how do we mitigate this problem? The best thing to do is to create a user and use the user command inside the Docker file when the container is built in order to run the processes as that user. There is a way to specify a user when you use the Docker run command, but that leaves open the possibility of forgetting to do that, and it's pretty nice that the image is just set up by default not to run as root. Also, pay attention to official images that you pull from Docker Hub, whether or not they run as root, or if they leave that up to you to figure out. All right, even though Docker provides you with the ability to set resource limits on your container, it doesn't automatically do it for you. In fact, the default settings are a free-for-all with no limits anywhere. So make sure you understand the resource needs of your application. Too little and your container will die from starvation. Too much and the container could smother others on the system. Using containers is not a license to be lazy and not understand your application and its needs, its resource needs. So those are also things, that's something that you're going to want to monitor and adjust over time as needed. It's a good way to determine if something is going wrong or if load on your system has changed for some reason. You can also use resource monitoring information to determine if your Application needs to be split up further with certain actions scaled differently. Lots of good information there. All right, never updating. This is a pretty big security issue. It's easy to get complacent and not pay attention to what is actually getting pulled in when you build images. Not only do you need to be aware of outdated versions that you specify in your own Docker file, but you need to pay attention to what's in the base image that it's coming from. Not updating packages and libraries inside your container can lead to some pretty embarrassing results, especially when there are tools available now to alert you when security issues have been discovered with specific artifacts. Even ensuring that you're running containers with a non-privileged user has risk when there are known vulnerabilities that exist within your container or even on the kernel of the host. From time to time, exploits are found that enable attackers to potentially escape a container. This is going to happen. There's no preventing it, so you have to, have a process that you can respond to quickly when these vulnerabilities are found, and have a process where you regularly update your stuff. So keep up with those security updates. I've definitely been on teams where this has not been a priority, primarily because of the fear of breaking a product or service that's already working, and that's a symptom of different problems. So trust me, it is much worse to leak private data or potentially be the start of a domino effect that can bring an entire system down than to work on the process of updating your containers. All right, this one's Java specific, and I love this image. It's kind of gross, but it's what happens if you aren't ready for it. If you are, you get something you don't expect. This is very specific to containerizing Java applications and is very much related to being aware of what your application requires to run successfully regarding memory. The JVM, as you know, is pretty clever at automatically determining settings for your swap and heap and your garbage collection behavior based on things like the memory and the number of cores available on the host. Remember earlier during our history lesson when I mentioned the dates for Java 7 and Java 8, when those came out? Considering the timeline of Docker development and Java releases, Java 7 and earlier versions of 8 and certainly earlier versions are not fully container aware. And this means that your Java application won't necessarily obey those memory and CPU constraints that you put on your container, and you may end up with some surprise out-of-memory killer activity. The reason for this is that the mechanisms that JVM used in these older versions to retrieve the resources available come from the actual host machine and not the C group limits that you would expect. So there were some improvements around container awareness that were introduced in Java 8, update 131, and further improvements in later versions. But to really get all of the benefits of container awareness, you really should get to Java 11. That's the latest available LTS release that is container aware. All right, image bloat. Pulling in large parent or base images that include a bunch of stuff you don't need. This just increases your attack surface area from a security perspective. And also shipping these large images around and storing them can become clumsy, slow, and even expensive now. When you're in the cloud, you're paying for everything, right? So start making use of the .docker ignore file to keep unnecessary items out of your images, along with paying attention to those base images and understanding how they're actually put together. I've seen in the past Docker files that not only have a large base image to start from, but they copy the entire source tree of a project, which includes tests, everything, etc. Actually, there's multiple problems here. If a copy, I see, usually when I see this, it's just a copy of the entire source tree in one line, even using, asterisks, using wildcards. It means that if anything changes, that layer has to be regenerated every build. So I would recommend organizing your code so that the stuff that changes the most often is in its own layer later in the Docker file. Think about implementations versus abstractions, for example. Making a big copy like that of the source tree, you're also possibly including your Git directory. You possibly may include secrets that you didn't intend. And even if you delete these things later in later commands in the Docker file, they'll still exist in those lower layers on the machine. So if you are pulling your source code into the Docker file, you're also likely including your build tool like Maven or Gradle. Sometimes people like to use their Docker files as instructions on how the project is built and packaged, having everything there, rather than just copy over a jar file, for example. If you're going to do that, learn to utilize the Docker's multi-stage Docker build so that you don't end up with all of those extra layers in your production image. You certainly don't need Maven in your production image, for example. And this problem is not limited to Java projects. I've seen this everywhere in other languages as well. All right, managing your images. Where are your base and your parent images coming from? Are you specifying a container registry in your Docker files? If you don't, the default behavior is to always pull from Docker Hub. That's how it's set up. So, and where are you storing your proprietary images? Public registries like Docker Hub, they certainly have their purposes. They're an awesome place to share official images and get some of your services up and running without starting from scratch. Good ways to share open source stuff. But I highly recommend using a private internal container registry. You get reliable access to required images for your builds. Avoid random failures in your pipelines because of network issues or a missing image. You'll have better control access to proprietary images. So there are a lot of free tools available out there. Of course, I'm with JFrog. So if you're new to container registries, at the bottom of this slide is a link to a dzone ref card that will help you learn more about why you should set up your own container registry and how. And then if you're curious about how an actual private container registry works and you just want to try one out for free, I've included a link here to JFrog's. It's a free SaaS version of the JFrog platform that includes support for Maven and Gradle artifacts as well as Docker and other OCI images. There's a lot of other features in there, including security scanning and pipelines that you'll be able to play with as well. That's pretty cool. The security for images is nice. Not only would you be able to tell if there's a vulnerability in your images, but you'll be able to tell exactly what layer is involved. So that's pretty powerful. The last resource on this slide is Foojay.io. When you build your own images with a particular JDK, because you should do this, and you want more specifics on what version or update to use, Foojay.io is an awesome resource to help you compare those Java versions and get detailed info on updates and compare the OpenJDK distributions. All right, that's all I have for you. I hope that you learned something new or just at least enjoyed this talk. If you have any questions, please throw them out there in the chat. Also, don't forget to go to this link in order to get a t-shirt or a Yeti.
Thank you, Melissa. And now I think we can move on to our Q&A time. And does anybody have any questions for Melissa? That's a very nice presentation. It's very cute too with the bananas. I love it. Yeah, I love the fact that you're not using like the usual containers, which is so boring, but you have bananas. It's like a different way of looking at containers. That's very creative. Thank you. So,
Hi. This is Sanjay. Thanks for the presentation. Good presentation. One question is whether you recommend to run the Docker image as a user's level or at the root level, as the root user?
I'm sorry, could you repeat that?
So you said something, right, about whether we have to recommend to run the Docker as a root user or as a separate user?
Oh, yes. So what you can do, you want to run as a separate user. So for example, I'm just going to use like a Postgres database, for example. If I have if I have that containerized and I launch that container, it shouldn't be running as root. It should be running as the user specific to that Postgres application that I'm running, right? So the way to do that, and also with your Java application, is in your Docker file, create the user as root. You start out as root, you create a user, and then you launch the process using that user rather than running it as root. Does that make sense?
Yeah, sure. Thanks. Another follow-up question is, let's say the Java has so many components, right? Java application is there, then file system is there, then database connectivity is there. So all of them as the same user level, user account, or do you want to use separate user accounts for each one?
Running the process would just be one user. Within your application, you can choose how to, access databases and things like that. Okay. That would be okay.
Okay, thank you.
Hi, Melissa. This one, I have a question.
Hi there.
You mentioned that there were some images that already had the user configured. Do you know some of them? Because I've never seen that. I mean, normally.
Think Postgres does. I think if you were to pull like a base Postgres image from Docker Hub, it doesn't run as root.
Okay. But do you know generic ones for Java applications?
So so usually I haven't worked with a lot of base images or parent images that are actually running Java applications. What I typically see is a base image that, may have, the operating system and like a particular JDK. So like Open JDK 8, for example, you can find an image for that on Docker Hub. And then that's what you start with. So obviously that's not going to do anything. You can pull that image, but it doesn't do anything. You make that yourself. So when you're building your Java application, you've got your Docker file and you use that base image. And then you configure your project and put in, either your source files or your jar file, however you want to organize your Docker file. And that's what you do there. Does that make sense?
Yeah, no, I was just asking because recently I saw that the Node.js images, they already have the user created on the operating system. So you just have to say user node, or sometimes you don't even have to set that. So it's
exactly.
By default, but the Java images that I've seen, the base one, like Alpine, that I see a lot of people use because it's so lightweight. They don't have any of that, or maybe I don't know, and they do have it, but yeah, that was why I asked.
Yeah, no, that makes sense. I usually see users being created and then those users being used in the Docker file, not in the base image, though, like you said. So what you said about Node.js, that's a perfect example. Some of these base images will not create a user and some of them will. So it's important to look at the source of those images that you're pulling in so that you understand what exactly is going on. It's a really good example.
Well, I just wanted to give one comment that in a project they had private images where they already added the user. So I think maybe that's one use case for private registries.
Yep, exactly. That would be something I've seen that as well. For example, you might have a development team that's working on Java. And in order to maintain consistency across the organization, you may be provided with the repository to pull your base images from. And exactly what you said, those base images are usually they come from, the raw form, and then a user is added, and then, developers go from there. That makes a lot of sense.
Yeah, that was it from my end. Thanks a lot.
Uh-huh.
Okay. Hi, Melissa. Another question is regarding the scaling up of the service, right? How the load balancing will work with the scaling up of the application, right? It's not like the application is not going to run in one node, right? We may run it in 30 nodes. How the Docker default will support that?
So that's where orchestration comes in, and this is why there's such a drive for people to go to things like Kubernetes.
Okay.
It's a learning curve, but that's where that happens. That's where a lot of that automatic scaling happens. Is definitely handled by the orchestration underneath.
Oh, okay. Thank you. So another question someone asked in the chat window, you can look into that.
All right, I'm going to stop sharing my screen so that I can, oh, there's the chat. Okay. What do we have here? Some recent, few months perhaps, news mentioned Kubernetes stopping Docker support. Yes. Okay. So they are actually going to use Containerd, which is the runtime that Docker uses, right? The difference is, like Docker, when you install it on your machine, you've got that long-running daemon, and Docker, you've got the client, you've got all of the ways that you communicate, and in order to launch your images and stuff like that. You don't need all of that in a Kubernetes environment. You just need the runtime. So that's what they've done. They've stripped everything else out. Docker was prepared for this. That's where Containerd came from. Docker started, getting features out and rewriting a lot of that. So it's you only get the pieces that you actually need. So that's really confusing when they say that we no longer support Docker. That does not mean that you can't run a Docker container using Kubernetes. That's not what that means. You can still, as a developer, have Docker on your machine, use the full package, create your images, and those images are OCI compatible now. They will run in Containerd runtime. You just don't need the full Docker experience on the server. And that's what they've eliminated. Did that answer your question? Awesome. Okay, good. All right, if no one else has any more questions, I actually have a question. For those of you, and I assume there are some, for those of you that are using Docker containers or containers in general, if you're not using Docker, what are you using and why? Is there anyone that wants to put in their 2 cents on that? Or maybe there isn't anyone not using Docker. There are other projects out there. There's Podman, Builda. There are other options. All right, I'm going to assume no one's using anything different. From the chat, do you have tips for better JVM containers, like building a custom JRE with JLink or compiling to native with GraalVM? Man, I am not going, I'm not going to recommend one specifically. There are so many to choose from. That's actually something I'm doing more research on for another talk, doing some comparisons and how we build these things. I know, some people in their development environments will throw in, the Maven plugin in order to build their Docker images, things like that. Some will use, very custom, lightweight base images. GraalVM is actually an excellent option for that. But Alpine is also pretty good as far as size. It just depends on what you're looking for. Also, Java 16, check out the, packaging, the new packaging stuff that has come out right now. That could be beneficial. That's something that I want to look at a little closer as well.
Okay. So the other question, I have one more thing. In your numbers, right, the percentage-wise, right, for 2020-21, is you mentioned Creo as 17% out of 100, right? Creo 17, DS 33, and Docker as 50%, right? And the Creo, that includes Kubernetes as well, when you say, because Red Hat accredited it, right?
That report, and there is a link on that slide. Let me go back to that slide. That report actually gives a lot of information on orchestration as well. Wait, it's harder to go back to that slide than I thought. Okay, here we go. There's a link on this slide. Definitely check it out because they have a lot of information in there. This particular graph does not show orchestration. It doesn't show Kubernetes. It just shows runtimes, container runtimes. But they do have additional information in that report that does have that data. So if you're curious, go check it out.
Oh, okay. Okay, thank you.
Mm-hmm.
Let's see. I think I see Jeff having a comment in the chat there.
Oh, I've used Bazel to create containers and then ship them to K8s. Okay. All right.
Yep. Yeah, one of the benefits of that strategy is you don't need to run the Docker daemon on your developer workstation, which can be nice.
That is nice.
The downside is, of course, you've got to buy into the Bazel ecosystem, which is can be kind of whole hog. You have to be very explicit about dependencies and stuff like that, which in general is a good thing, but it's a bit of a learning curve.
I think my biggest thing is that, I'm stuck with my Mac. I just want to work on my Mac. That's where I have all my tools. I don't want to install a whole nother VM. I'm kind of lazy that way. So is Bazel something? Is it Linux based? Is it something?
It's written in Java. So if you're shipping, a Java application, you probably already have a JVM. Although I think there's some Bazel self-contained installers that ship a JVM as part of their installation, which some Java tools do, so that you don't have to worry about it, so that you don't have to manage the JVM itself. If that makes sense.
Yeah, that makes sense. And I assume, it's OCI compatible. It must be if you're shipping them to K8s. Cool.
Yep. Yeah. Bazel is an open source version of Google's Blaze build system. So they were used to building containers before Docker, and so I think this is kind of their port of doing that, but in a Docker ecosystem.
Makes sense.
Another tool for your belt.
Awesome.
Can I ask a crazy question? I don't know if it's crazy or not, but so my understanding is doing so normally we do microservice is some specific functionality and then we package it up, containerize it. But is there a real life scenario? I guess theoretically you can actually have a container that's made up of different kinds of components, right? You can have Java and maybe and you can also have some JavaScript and just package them up in a container. But should we? Yeah, or should we do it, or is it depending on circumstances? Can we actually have multiple polyglot kind of microservice packaged up in one container? Or have you seen examples of that, and would that be a recommended thing to do?
Yes, I've absolutely seen that. Usually I see things divided up in front end and back end, right? And then that's the first step. And that usually eliminates, any coexistence of JavaScript and then a Java server backend, right? It just makes more sense. The front end has such different requirements. So I wouldn't suggest putting everything together. What's the point? You've got your monolith all together in a big container. So you kind of lose the benefit of containerization doing that. So I definitely, as a first step, definitely split out the front end activity with the back end. Now for the back end, depending on usage, I worked on a project once where every single action was contained in a single service. And that was fine for a while until it was out in production and we were monitoring it and we noticed that a particular service gets a heck of a lot more usage than something else. Or we have a service that takes up a lot more memory, you know, stuff like that. And then like any other request dies because that one is busy hogging the whole thing. So that's an opportunity to then continue to split things out and move services out and scale them differently.
That's okay. Thank you. Right, and looks like we have Kwan who just posted a question.
A lot of production DBs on containers. I've seen a few. I think it just depends on the size of your data set, right? And what you're actually doing with them. I know like for something that's pretty heavy hitting, I probably wouldn't put the database in a container. I mean, usually I've seen huge servers where all it is, you know, the database, which was beneficial for that particular project. But where a database in a container is super useful is in your testing environments and your local environment, right? Super easy to spin up a database and verify functionality with a real database, but have it be ephemeral and not have to go through all of that setup process when you're testing your stuff. Test containers that's a good place to go for stuff like that. Oh, cool. Thanks for posting that link.
Okay, thank you. Thank you. So do we have any more questions for Melissa? Looks like it's good. And if not, then I should ask one more time if anybody has questions for Jürgen too, because Jürgen is still here, right? About Foojay.
Still here, and it's 2:30 in the morning where I am.
Oh, wow. Oh, that's right. You're in Netherlands. Yes. Okay.
This is the nature of online events. They're all times.
I forgot. Yeah. I guess we can connect with you on Slack and ask you questions next morning. So if we have questions.
Anytime. Yeah, but Mary, you are on the Fuji Slack already, so please feel free to spread the word and you know about that Slack channel. It's really meant to be for any questions about Java in general, or as somebody asked about Intellij idea. That's where you could ask questions about that, because in the case of Intellij, there's a developer advocate from JetBrains who's also on that Fuji Slack channel. So it's really a central place where you can ask anything about Java.
Yeah. Okay, great. Yeah, that's awesome. Yeah, I'll tell my members of my community to, if they want, I'll send them. I should be able to invite them too, I think
so
right?
too, yeah.
Enable.
Perfect.
Yeah. Okay.
Perfect.
Yeah, sounds good. Thank you. Yeah.